Hello students, how are you all? Keeping fine? Okay. So today we will see a new topic in the chapter acid, bases and salt, which is salt. Okay. We have studied acids, we have studied bases, and now we are studying salt. Okay. So you know what is a salt? What is a salt? Salt is made by the neutralization reaction, isn't it? That means whenever an acid react with a base, what you will get? You will get salt plus water. So this is how a salt is formed. So this type of reaction you call it as a neutralization reaction. We have studied so many type of reaction, isn't it? Displacement reaction, combination reaction, double displacement reaction, etc. So neutralization reaction means whenever an acid reacts with a base, you will get a salt and a water. And the best example is HCl, a strong acid and a strong base, that is NaOH, will give you salt. What is a salt? Salt is NaCl, that is NaCl plus water. So definitely water will be there. And how the water is formed? By this H plus ion combines with this OH minus ion. See, H plus OH will give you water and the remaining will go for the salt. So and another example, HCl plus KOH. Again, what will you get if you say water is removed? Okay, water is removed. What is the salt? KCl. KCl plus water. So this is how a simple or a normal salt is formed. That means by replacing water from the acid and base, you will get a normal salt. Okay. So when I talk about normal salt, is there any other salt you are thinking? Isn't it? Actually, salt can be classified as simply, okay, just for information, additional information, salt can be classified as normal salt, okay, which we have seen, that is by the removal of water, the full removal of H plus and the OH minus ions, okay, full removal of the H plus ions and the OH minus from this as water, the resultant you will get it as salt. That is called as normal salt, that is neutralization reaction. Again, there can be acidic salt. See, what do you mean acidic salt? Acidic salt means there is only a partial replacement of H plus. For example, let us give an example. NaHSO4. See, there is an H here. So, in acidic salt, it must contain an H. Likewise, in basic salt, it must contain a OH minus. See, at least one. That's what? At least one. At least one. Okay, so that is the difference between acidic salt and basic salt. So there is only a partial replacement of H plus ions. For example, this again will form what? Na2SO4. This is a normal salt. There is no hydrogen ion. Okay, this copper sulfate. This is a normal salt because there is no water, H or OH minus. But if it contains an H in a salt, it is called as an acidic, simply say. Okay. And here in a basic salt, if there is an OH minus other than the anion, it is called as a basic salt. But if you remove this H and OH, you will get the normal salt, which is, for example, NaCl. See, there is no H and OH minus. Okay. So this is a normal salt, this is an acidic salt, this is a basic salt. Then some more salts are there. If we go to higher classes, okay, there are mixed salt. What is a mixed salt? Yes, mixture of salt. What do you mean by that? There are more number of anions and cations. Okay, there are more number of anions and cations. For example, bleaching powder. Okay, calcium oxychloride. It consists of Ca2 plus and O2, O minus and OCl minus. Okay, don't go for into that. Just you know that there is also mixed salt. Okay, again there is also double salt. What is double salt? Double salt means two salts put together. Two salts when put together you will get a double salt. Okay. Some examples are more salt than water. So just no need of that. Just you should understand that there are so many kinds of salts. And what we are putting into it is normal salt. That is there is no hydrogen or OH minus ions in that salt. So our interest is of normal salt. Okay. Okay. Now, if I write a salt, for example, potassium sulfate. What is the formula? Is it right? No. It is K2SO4 because it is 2 minus and plus 1. So it is K2SO4. Okay. Now tell me, which are the acids and bases to form this salt from this formula? By seeing this formula, a question can be asked, what is the acid and base to produce this salt? So you have to take like this. Okay. Now what you will say? This is SO4. Now what will be the acid? That is H2SO4. Isn't it? H2SO4. So the acid is H2SO4. And what is the base? What is the base? K, right? Then putting an OH into K. That is KOH is the base. So by this you can say which acid and which base combines to give which salt. So you will give some salt. For example, calcium chloride. Tell me which acid and which base. You know, metal. This is a metal, right? Metal will always go for the hydroxide side. Okay. So this is HCl. So putting an H to Cl, that we will get HCl, and putting an OH to Ca, that is calcium hydroxide. Valency you must satisfy. Okay. Then again, some salt like sodium nitrate, NaNO3. NaNO3. What is that acid? Putting an H to the nitrate ion, that is HNO3, and putting an OH to Na, that is NaOH. So by this you can find which is the acid and which is the base in order to form the corresponding salt. Clear? Okay. Now there is a table in your textbook. There are so many salt have written in that. Okay, there is an activity, I think, and there are so many salt in it. So what you have to do is you have to just write the formula for that salt. Okay, for example, sodium sulfate. So many salts are there in your book, in an activity given in your book. So you write that formula for the salt. Then you have to write what are the acids and bases for that corresponding salt in your science book. Okay, so you have to do it as a homework. Right. Now we will see more about salts. For example, have you heard of family of salts? What do you mean by family of salt? Say, if there are same positive ions and negative ions, for example, I will give an example, NaCl, Na2SO4, Na2CO3, etc. We can say all these salt, what is the acid? HCl, what is the base? NaOH. Correct? Right. Okay. Now here, what is the acid? H2SO4 and NaOH. Correct. Why you put Na2 here? In order to form the valency. Isn't it? The chemical compound. Writing the formula, you have to take the valency. So no need of Na2. Some children will get the mistake as Na2OH and HSO4. No. We have to see the valency, right? For writing the formula. You can't write sulfuric acid or as HSO4. Why? Because SO4 is 2 minus and H plus is plus 1. So how will you cancel out? So it must be H2. Correct? So please look to that. Okay. So here it is NaOH. That is OH is minus 1 and Na is plus 1. Now tell me what about Na2CO3? What is the acid? H2CO3. Isn't it? Because CO3 is 2 minus. So there must be 2 plus. Then only it will become 0. The formula is right. Now, then what is the base? NaOH. Is it Na2OH? No. It is NaOH. Because the valency of OH is minus 1. Na is plus 1. Okay, so you just write all the salt and acid and bases. Okay. Now what we were talking about is, if you write this, you know that these all the salts contain same cation. What is cation? What is cation? Cation is positive ion or radical. Positive ion is radical or positive ion is called as cation. Okay. So in this case, all the salt is having the same cation as Na plus. Correct? Now we can say all these salt belong to, I can write family of which salt? Sodium salt. See? Family of sodium salt. Why? Because it contains the same cation for all the salt. If there are 5 salt, if the 5 of them carries the same cation or the positive charge, it is called as the name of that family. Or any one example. One more example. If I say NaCl, KCl, CaCl2, LiCl2, okay, sorry, LiCl, etc. Okay, BaCl2, okay, right. In this, which is a common ion? That is Cl. See, all these salts contains the common as Cl minus ion. But minus ion is called as what? Anion. Plus ion is called as cation. Minus ion is called as anion. Okay. So in this case, you can say what is the family called as? The family of chloride salt. Isn't it? The family of chloride salt. So you can write like this. The family of chloride salt. Okay. So this is what you call it as family of salt. Family of salt means if the salt, all the salt contains one common ion or radical, then they can call to be as the respective family. Okay. So that also you must note it. Okay. For this also there is one activity in your textbook. You just copy it and then write the family of that salt. Okay. First you have to write the chemical formula. If there is any mistake in the chemical formula, you will get wrong. Okay. So please make sure that you are writing the chemical formula right. Okay. Now even somebody is not knowing the chemical formula, just tell me, I will help you. Okay. Because without, I always say that without balancing, you cannot write a chemical formula. And without a chemical formula, you cannot write a balanced chemical equation. And without a balanced chemical equation, chemistry is nothing. Okay, so the fundamental is what? The balancing. So please, if somebody doesn't know the balancing, you just go to the 9th standard or just come to me. Have a WhatsApp chat with me and I will come to you. Okay, so please make sure. Okay, so that is about the family of sodium salt and family of chloride salt. So got it? Understood? No problem? Okay, now we will pass on to the very simple salt, that is our table salt, which you call it as rock salt also, that is sodium chloride. This is called as table salt, isn't it? You put in your table. Okay, this salt is used in our cooking purposes, isn't it? Our day-to-day lives we are using this salt. Now talking more about sodium chloride, this is called as sodium chloride. So one more thing I want to say is, if a question asks you, write the chemical name of NaCl or chemical name of salt, common salt. You say it as common salt or table salt or rock salt. Or if the question says write the chemical name, you have to write the chemical name sodium chloride, not the rock salt or the common salt or the table salt. Okay, so keep in mind, chemical means you have to get the chemical name correctly. And if it asks what is the chemical formula, you have to write the correct formula. Questions can be asked like that. Okay, in board exam. So make sure. So this is sodium chloride. So now we will see in detail about this sodium chloride or common salt. And you know there is a history behind this common salt, isn't it? In your history chapters you have studied about the Dandi March Is it salt satyagraha, which is led by the Gandhiji, isn't it? Our father of nation. Okay, so you know the story about that. So from very beginning, you know about this common salt. And how you will get that common salt, or you know what is salt satyagraha, no? Okay, so from the seawater, we are getting the common salt. And seawater contains so many dissolved salts, isn't it? Not only the sodium chloride, there are so many salts which are dissolved in it. Dissolved means we cannot see that. We have to filter it out. Okay, so we have to purify the salt. So you know, by making the buns, by evaporating the seawater, you will get the salt and then you will purify it. Okay. So from seawater, you can get the salt or the common salt NaCl. Now, also, you can get the seawater, the common salt from the rocks, or you can get it from big rocks, rock-like structure. If you dig it, it is like brown in color. It is brownish in color. Why brownish in color? Due to the impurities present in it, it will be a brown in color, and it appears as rock crystals. And from these rock crystals, you can get this sodium chloride, and then you purify it, you will get sodium chloride. So that is called as rock salt, because it is getting from a rock-like structure. Okay, so you can dig it, and the same way as we dig in the coal mines, isn't it? You can dig it. Okay, so there also you can have what? There also you can get the sodium chloride. So by so many methods, you can get this sodium chloride, a common salt. Then, so this is about the somewhat introduction of this common salt. It has got a great history, and sodium chloride is nothing but the common salt which is used in the day-to-day lives. And you can get it from the seawater and also from the rock salts. Okay, now if the drought all happens, what happens? The sea, the ocean, they are all dried up. Okay, so then also you can dig the salt, the rock salt, in the form of rocks. Okay, so there you can get the rock salt, the sodium chloride. Or another name of sodium chloride is rock salt. Okay, so then you will, now you will see this importance of sodium chloride. Okay, or you can use the sodium chloride as a raw material for so many other useful substances, which we can see in our day-to-day life. Okay, so now we will start with sodium chloride. Okay, now sodium chloride. Okay, now we will see now the sodium chloride as a raw material. What do you mean by raw material? What do you mean by raw material? Raw material means there is something to start with, or by starting from this material, you can have, or you can make some other material. So that is raw material. Okay. So from this sodium chloride, you can prepare so many raw material. So many materials which are useful to us. For example, sodium hydroxide. It's a very useful component in chemistry. Okay, in laboratory, doing experiments, etc. So you can prepare sodium hydroxide. Then you can prepare, baking soda. You know it? Baking soda, your mama will know it. Okay, baking soda, which is used in getting pakoras and all. Okay, frying pakoras and all. Then you can have baking powder. This also you will know, because you are very fond of cakes and all, isn't it? So in this cake you will add baking powder. Then again one more example from sodium chloride, you will get bleaching powder. Bleaching powder. Okay, bleaching powder is, an insecticide, isn't it? Okay. So, or purification of water, or in swimming pools you can have bleaching powder. Okay. So, for making of all these things, you will use NaCl as a raw material, or simply says sodium chloride is used in bringing out what? In order to make sodium hydroxide, then baking soda or baking powder or bleaching powder, anything. Okay, so we will study one by one. Now first we will study about the production of or making of sodium hydroxide. What is it? Sodium hydroxide, which is called as NaOH, or you can also say it as caustic soda. And another name of sodium, this is not a chemical name, remember, chemical name is what? Sodium hydroxide. Okay, this is just a nickname, that's all. Okay, caustic soda. Have you seen sodium hydroxide? It is seen as white pellets. There are certain terminologies in pellets. Okay, there are certain terminologies in chemistry. Like we don't say sodium hydroxide crystals. You will say sodium hydroxide pellets, or you will say zinc granules, copper turnings, etc. Okay, so the sodium hydroxide is somewhat whitish in color, which you call it as sodium hydroxide pellets. Okay. Now, if you tell about the nature of sodium hydroxide, if you kept this sodium hydroxide in atmosphere for a while, it will become liquid. What is that? Because how liquid is formed? The sodium hydroxide pellet will turn into liquid. Okay, so that's the peculiarity of the sodium hydroxide. Now, how you can prepare sodium hydroxide from NaCl? And the method is called as, listen, chlor-alkali process. Okay, what is the method called? Chlor-alkali process. Chlor-alkali process. Okay. Now, by this process, you can produce, or you can get, or you can form sodium hydroxide, or you can produce sodium hydroxide. Now we will see what is exactly this chlor-alkali process. Something related to, see, from the name itself you can have some idea about what is this. This is chlorine is there and alkali is there. You know sodium hydroxide is an alkali, and you know it is a corrosive base. What is corrosive? Fuming. Isn't it? It's a fuming base. It's a corrosive base. Whereas soda, baking soda are all non-corrosive base. It is not corrosive. So sodium hydroxide is a very corrosive base. So here there is an alkali which is sodium hydroxide, and chlor means chlorine. So we will see what happens in this process. See, our raw material, one of the raw material is sodium chloride. Correct? Now, if an aqueous solution of sodium chloride, what do you mean by aqueous solution? Aqueous solution means sodium chloride in water. Aqueous solution. Am I right? Okay. When this sodium chloride, aqueous solution of sodium chloride, when electricity is passed through it, what happens? When electricity is passed through aqueous sodium chloride, there is another name for aqueous sodium chloride, which is called as brine water. See, what is it? Brine water. So you can also say, when electricity is passed through brine water, what will happen? This sodium chloride gets decomposed. Aqueous means there is water, right? There is water. So sodium chloride, on passing electricity through aqueous solution of sodium chloride, the sodium chloride decomposes to form what are products? Hydrogen plus chlorine plus NaOH. See, three products are obtained, that is sodium hydroxide, which is an alkali, chlorine, which is called as chlor, and since these two are obtained in this reaction, that is called as, this is called as a chlor-alkali process. See, chlor-alkali process. Okay, so since chlorine and sodium hydroxide. Now tell me, what is this kind of reaction? On passing electricity, some reaction is happening, and I have already told you a decomposition happens. So tell me, what is this kind of reaction? You have studied by passing electricity. I will give you a hint. You have studied the decomposition of water into hydrogen and oxygen. So what is that decomposition called? In presence of electricity. So what is that called? Electrolytic decomposition. Am I right? Yes. So this also, in this process also, electrolytic decomposition happens. That is why electricity is passed. So on electrolytic decomposition of brine water, it decomposes to form hydrogen, chlorine and NaOH. Now the question is, Where electrolytic decomposition, where you studied in the water, there was an anode and cathode, right? Are you remembering? The carbon rod as anode and carbon rod as cathode. So there must be a cathode and anode in this reaction. So in the same way, here the hydrogen is liberated at cathode. Remember very carefully, cathode, because questions can be asked where the hydrogen is evolved or at which electrode the hydrogen is evolved. At cathode. Okay. And the chlorine is evolved at the anode. See? And in the solution, NaOH will be there. Exactly, the solution is NaCl. But in that solution also, there is a quantity, quantity of NaOH or alkali is there. And that too in the cathodic side, where this hydrogen is there. Okay, so what are the products? Hydrogen, chlorine and sodium hydroxide. And where this hydrogen is liberated? Cathode. If you want to remember, how you can remember hydrogen at cathode? See, I am remembering like this, Hc, that is High Court of Kerala. High Court, Hc. Okay, like that. Okay, so whatever mnemonics you want, you can have. So no problem. Okay, so hydrogen is at cathode, chlorine is at anode, and NaOH is getting at near to the cathode. Okay, this you will study in higher classes, from where this NaOH is coming and why this. See, it is Na and Cl, right? You must be remembering. Some of you must be having some question in your mind. Like, see, teacher, NaCl is here. Now, how will you say that where this hydrogen is coming from? Isn't it? Okay, there is water, but why happens or how that happens or what is the mechanism of that? That we will study in the higher classes. Okay, that is the electrolysis product. Depends on so many reasons. Okay, on standard electrode potential, etc., etc. So don't go for it. So just remember, hydrogen at cathode, chlorine at anode, and NaOH near the cathodic solution or the cathodic electrode. Okay, so this is called as chlor-alkali process. So you got it? Clear? No. Now what happens is the uses of this hydrogen, chlorine, and NaOH. Just two words. What is hydrogen used for? Hydrogen is used for what? To make hydrogen bombs. Yes? Then it is used as a fuel. It's an economic fuel. In fuel cells, I don't know whether you have heard it or not, in fuel cells, hydrogen is used. Because this is an eco-friendly. Okay, it's an eco-friendly fuel cell. So in that, hydrogen is used. Okay, then again hydrogen is used in the manufacture of ammonia. You know what is ammonia? For the fertilizers, NPK, nitrogen, potassium and phosphorus. So for that, the hydrogen is used in the manufacture of ammonia. Okay, for plant fertilizers. Then again hydrogen is used in margarines. What is margarines? That butter. Okay, butter. So in all these cases, the hydrogen is used. Some one or two examples we have to study. I mean, uses we have to study because it can also come for board exam. Now, what about chlorine? You know, chlorine is what? Chlorine, if you put in water or in well to clean the water, isn't it? Purification of water, you put chlorine. Then, chlorine is also act as an insecticide for killing germs. But the level of the chlorine will depend. Okay, sometimes in your home, at some point of time, if the corporation water is coming at your home, not from the well means it is pure water, but in still, well also you will put that's chlorine, okay. But still sometimes we can smell the chlorine in the tap water which the corporation is sending us, okay. So just, and also in swimming pools, if you know, if you are a swimmer, if you go for swimming, you can have the smell of chlorine in that pool. Okay, so for what? For the cleaning purpose. So for all that, chlorine is used. Okay, for then again for the manufacture of PVC. You know PVC pipes in your homes, right? Polyvinyl chloride. So chlorine is there. So many uses of chlorine are there. Okay. Now NaOH also there are uses of NaOH. NaOH can be used as a lab reagent. Okay, there it is a lab. Okay, then for cleaning the utensils or metal particles, metal parts, etc., NaOH is used. Okay, so these are some of the uses of hydrogen, chlorine and NaOH. Okay. Now one more thing. This hydrogen and chlorine, if you combine together, what you will get? You will get HCl. Isn't it? When you combine this hydrogen and chlorine, you will get what? HCl. And what is HCl? Hydrogen chloride. Isn't it? Now it is very soluble in water, or if you mix with water, it is soluble, and you will get what? Hydrochloric acid. Now what is this acid used for? It has many purposes, isn't it? Acid is used for cleaning purposes, it is used as a lab reagent. So there are so many uses in that. So this is all about today. That is a simple topic, that is the first thing, that is the production of NaOH. Okay, from where? From NaCl. For NaCl as a raw material, the first thing to obtain is NaOH. Okay, so now what you will do is, you can have a flow chart on this. Okay, in your textbook it is given like that. That is hydrogen, chlorine, NaOH. Then the uses of hydrogen, the uses of chlorine and uses of NaOH. Again, the hydrogen and chlorine will give you HCl and the uses of HCl. So you have to draw that flow chart in your notebook. Okay, so that's all. Prepare your notes. Any query, get to me. I will clarify that. So till then, thank you.